Hello everyone. Can you hear us well? We are going live with our webinar for NaNLABS. I'm checking if I get any answers to make sure that everyone can hear us. Let's see. Yes, I think we're live and we're good. Great. So hi everyone. Thanks for joining us today. I'm Daniela, Head of Marketing at NaNLABS, and we're here today to dig into the world of cloud complexity. So basically, we're going to help you untangle the cloud knot and share some practical tips to boost your cloud infrastructure. For those that may be new to NaNLABS, if you've never heard of us before, we are your tech sidekick for all things data engineering. For over 11 years, we've partnered with more than 150 companies across the US, solving data challenges and delivering effective solutions that actually drive meaningful growth for our customers. Our team, an amazing people team sitting in Buenos Aires. Buenos Aires is a tech talent hub with the highest English level of the region and an ideal time zone overlap with our customers in the US. But enough about us, because I'm really thrilled to introduce to Gustavo Alberola, who's here with me. He's our go-to AWS and software development expert. He'll guide us today through the session, sharing useful insights along the way. Hi, Gustavo. Thank you so much for joining us today and for preparing this amazing session.
Hello, everyone. My name is Gustavo. I'm a software developer advocate here at NaNLABS. Well, today we are talking about complexity and the cloud and how to survive, hopefully.
Yes. So thanks again for being here. Just a quick note before we dive in. If any of you have any questions throughout the session, feel free to send them through the chat. We'll have a Q&A session at the end to answer all of them. So without any further ado, let's get started. Gus, the floor is yours. I will share your presentation. Let's make sure
Awesome.
you can see
I don't see anything from here, so let me know when we are ready.
I think now everyone can see you and the presentation. So I'll leave you to it. Thank you and good luck.
Awesome. So good morning, good evening, good afternoon, wherever you are. Let's jump into it. Talking about complexity. The first thing that I want to talk about, because this might be a catchy title, but what is actually complexity or what we mean for it? Like the first point that I want to recall is what I call in-your-face complexity, or it's just the sheer amount of stuff. Like the first layer is going to be the amount of services, and each icon in here represents one service that AWS has. So this is the first step into understanding complexity. It's just way too much. But let's zoom in a little bit, because this is not just the whole picture. Let's look at one particular service, like EC2 in this case. If we go to the UI of EC2, we will find something like this. And the things that I want to focus on, there are these pods, like instances, images, EBS, network security, yada yada. All of these represent features inside a particular service. So now we are multiplying. We have services, and each service might have a bunch of features behind it. So we keep increasing complexity and the size of the whole problem. But that is not the whole thing, because now we need to look about, when we talk about cloud providers, we need to look at abstraction. And the way I see it is kind of on a high level and a low level. Think about like programming language abstraction. Like the higher the abstraction, the least things that you need to rationalize or know about it to either use or operate a service. The lower level the abstraction, the more you need to know. For example, if I try to create two different services, for example, and I don't want to focus on the actual underlying things, so blurring magic. On the left, I'm trying to actually create a Kinesis data stream and just see the amount of things that I need to configure. Like in this case, it's an on-demand. So it's basically deciding the name of the service, and that's it. In the right is an actual VPC. So we have something like 2 settings versus something like 14 plus settings. Like that is also a lot of complexity comparing one versus the other. Like again, things that we need to know and rationalize how to use them and how to operate them. So I put this into a lovely formula that I want to call Gustavo's super original formula to calculating the complexity of the cloud, patent pending. So the amount of services that we have multiplied by the amount of features that each service has, multiplied by the level of abstraction, is what is going to give us the complexity of the cloud. And the idea for this whole presentation is to try to break down this formula, try to find some tips or guides how to navigate this complexity, and hopefully land in the services that will fulfill our business needs and help us be better engineers. So, and a little bit of the agenda, I want to just give a glimpse of a history of how did we get here. Sometimes it's helpful to understand. I want to give you some tips how to compare services and how to think about comparing services. Then I will give some more specific tips for developers, and then some more specific tips for CTOs or tech leads. And if we have some time, we will jump into a Q&A. So first of all, how did we get here? A little bit of history. I want to paint the context. This is something like 2004. And to give an idea, Gmail was just getting started. And you actually need an invitation to create a Gmail account. So fancy. Social networks and social media, it was mostly blogs and news feeds. That was it. And then we had the recovery of the 2000s .com bubble that was just appearing with some Web 2.0 conferences, those kind of stuff. But in terms of AWS, what did it mean? If we look at the services on some of the early years, for example, AWS started with SQS, Simple Queue Service. 2 years later, they published another service, S3, Simple Storage Service. I don't know why they have with the simple stuff. EC2 for compute on the same year. Then 1 year later, trying to develop a service that was to doing database managed by the provider, SimpleDB. I don't have an icon because the service is no more, but it was launched at that time. 2008, CDN. 2009, we finally have UI. It's not just APIs. Congratulations. And we have a VPN. But, sorry, VPC. But now let's put it into context. Let's say that is 2009-ish or 2008. And we want to create a service. And I'm going to pick the really original idea of creating a web service to upload and share images of cats. How that will look like? Well, first we need a service. We need to host it somewhere. So we have our cat server. We will choose something like an EC2. We can deploy a PHP server, for example. Now we can send requests to that service. We have users. We most likely want to store those users and their cat preference somewhere. So either it's a SimpleDB that at the time existed, or we run our own database on EC2. And we also want to store the pictures of the cat somewhere. Then we rely on S3 to actually store the pictures. And maybe your web service is actually really successful and we are starting showing pictures to all the globe. Well, we might want to speed up how fast do they receive the pictures. So we might start putting a CDN in front of the images. And what about some really fancy features? Like let's imagine like Instagram for cats. So applying filters, that kind of stuff. So we create a new service that will add this image manipulation functionality. But I don't want to sully my beautiful architecture with just direct coupling between two services, between the cat server and the image processing. So I introduce a message queue in the middle to couple them. So we have some asynchronous processing, so SQS is the right fit. And this will be a typical request response web service application in 2008, 2009. And to be honest, you can see some similarities from nowadays architecture. You might have more knobs and more things downstream, but the idea is still there. But these are all the services that AWS launched until this day, and we're using all of them. But the question is, like, where do we start getting into like these 7, 8 services to the amount that we have today? And we did a histogram of all of those. And we can start seeing like the first year we have like from 2004 to 2010, like 21 services. Good number, but 2014 versus 2020, we jumped from 54 to something like 200 plus, like more than 100 services. Like the deltas are getting quite obscene at some points. But we are getting a plateau. So it's not that we will reach the 3 million services soon. I hope, I expect, please. But still, there is a lot of complexity in just the sheer amount of services. Now we need to somehow choose the right one to our particular use case from all of those. Like, it's getting tricky. And the last bit from history is that when I saw this, my question was like, is AWS fault? Like, was AWS the mastermind behind this, saying like, ha ha ha, I will create 1,000 services and rule the world? But the idea is like, if we look at the industry as a whole, like this is a picture for the CNCF, and you can start seeing the explosion of services. Like, it's not just AWS. And if you look at other cloud providers, it's kind of the same. So it's just the industry trying to push more business towards us, maybe in the form of free software, which is some platform behind the scenes, but it doesn't matter. The point is that there is a lot, and somehow we need to learn to cope with it. Like, it's the only choice that we have. So let's go into the more practical stuff. And when we think about services, the first question that we need to understand is, how do we compare them? Because in the end is, I want to do something. From all of those, which one do I choose? And how do I choose the one that fits the most? So going to the trusty function that we did today, we start at the first level, which is services. And we start with the obvious. Like, for example, do I need satellite image for my web service? If the answer is no, AWS ground extension, we don't need you. Do I need a giant truck with hard drives that is going to come to my data center, plug it in, copy all the information, drive to AWS, and upload it so I have it on the cloud? If the answer is no, maybe we don't need any of the Snow product family. What about quantum computing? Do you need it from our cat sharing, picture sharing web service? Probably not. So Amazon bracket is out of the question. And if you actually have been using AWS for a time, you saw some changes on the UI. Originally, when you go to services, like, you were presented with the list of all the services that AWS had. But nowadays, you actually see logical groups. So this is AWS saying like, okay, we understand there is some complexity. We are trying to simplify this for you. So instead of showing everything, tell me what you are trying to do. So for example, in this case, we say, hey, we want to choose from a database. What do you have? Okay, these are the 9 services that fall into the category. So we pass from 200 plus to something like 9. It's a really good start point, but not enough. So that's the service. Now we jump to the next layer, which is features. Let's keep with the example of the database. And let's say that I want to choose something between a relational database like MySQL, DynamoDB, and Cassandra. If you look at the service layer and how AWS, for example, was grouping them, they all fall into the database layer. So not enough. We need something else. So we start looking at the features. And this is one of the key points that I want to emphasize that helped me a lot. You can start looking immediately into the particular features of a given service. So for example, LDS, Dynamo, Cassandra. Or ideally, you can start trying to look for commonalities or subgroups that actually encapsulate similar features. So for example, in the case of databases, we find 2 groups in here. Like, we find the relational databases, and in this case, the wide column databases. What do we do here? we shrink the complexity from 3 services to now a decision between 2 groups that share similar features. So let's focus on the features for one. Let's think about data modeling for databases. I'm going to be quick because this is not a database talk, but bear with me. Relational databases, for example, how you model, you think about normalization and tables and relationships, or primary keys, foreign keys, that kind of stuff. But white columns is more about denormalization and sharding. Like there is a different way how you think about your data and how to model it. And if you think about the process, relational is about you first look at all the data that you have, then you build the models, which is the table and relationships, and then you look at the access patterns and build your queries. White column is a little bit changing the order. Like you look at your data, again, the first step, but then you start looking at the access patterns. Like this is very important because the access patterns is the thing that will shape how you model data. So primary key, primary sort keys and GSI, they will all be influenced by what are your access patterns and what you're trying to do. So the order changes. And in terms of scalability, relational is more about vertical, white column is about horizontal. But again, the idea is that somehow we found a way to simplify instead of trying to look at the individual services, to try to look for groups that encapsulate common features. And that is a way to also remove complexity. So let's say that I want to go with the white column because I need the horizontal scalability for some reason. Now I remove this, and it becomes a question of DynamoDB versus Cassandra. And I have to be honest, it was a little bit of a nasty example because Cassandra is actually based on DynamoDB. So they all belong to the same subgroup. So we expect to share the same features, so this is not enough. Now we need to go to each individual service. And this is tricky because if Cassandra is based on DynamoDB, shouldn't be the same? Well, what you need to do in this case is where are you going to run it? Like, let's ask AWS. And the answer is, like, Cassandra actually based on the AWS implementation does not support indexing. While DynamoDB actually has indexing in the form of GSIs. Actually, you have other, but GSIs is the one that you will use the most. So now it's AWS dictating an individual feature, which one do we need to use? So if you need indexing, or do you foresee that you will need indexing, then the answer is you need to go with DynamoDB. Otherwise, pick the one that you like the most. So we filtered from services. Now we went to a deeper level with features. But another consideration that we need to take into account on the cloud is the abstraction. And we talk about abstraction as how to use a service, but also how to operate a service. So in here, the typical example is EC2 versus Lambda. Let's do a simple comparison. And I'm going to draw some colors, like yellow is going to be AWS is responsible for, so I don't care, just deal with it for me. And blue is customer, which means us. So now we need to deal with that responsibility. So first layer, hardware, the physical box that is going to run our stuff. Unless you have access to an AWS data center, which I don't have and I don't want to, this is AWS responsibility. Virtualization, sometimes the hardware is multi-tenant, security stuff, AWS responsibility, I don't care. We reach the OS layer. Now we start seeing a change. If it is EC2, OS is your responsibility. You can have the AMIs and can is pre-installed for you at some configuration, but you are the owner of it. And we'll see that it has some ramifications when you start going to the sites. Runtime. Sorry. Let's say that you package your application using something like a container, like Docker. Well, you will need the Docker runtime or some container runtime to execute your code. Otherwise, it's not going to work. Your responsibility in EC2, Lambda, you don't care. And finally, the code. This is your code, this is your dependencies, your libraries, all that entails. If we start looking at the size, the first thing that I want to consider is security patches and security updates. Like if you think at the top level of the code, is basically vulnerabilities that they found on the dependencies that you're using in your libraries, or maybe your code. But in C2 also you have the other one, which is runtime. If something happens with the Docker container, new version, security vulnerability, you have to patch it, it's a responsibility. Same with the OS. Security vulnerability, go run in and change all your services deployed to install the hotfix. Virtualization, not my problem. The same with Lambda. And in terms of Lambda, we only care about the code. What about role-based access controls? The same, like what your code has access to. Does it need to reach a database? Does it need to read permissions? Your responsibility. But also, for example, who can SSH into your EC2 instance? That is a lower level, but still your responsibility on EC2. On Lambda, you don't care. The only thing that you care is about your code. What about scalability? I put it as a gradient because EC2 there is a setup initially. Like you need to define the rules that will govern scalability. Ideally, once that is done, scalability is being handled automatically. But you might not configure it the best way and you might run into trouble. So there is some responsibility. So that's why I put it into a gradient color. Lambda, you go to documentation, they say this is how it works, this is how we deal with spikes, and that's it. Yes, you have something if we talk about pre-warming lambdas and those kind of stuff, but that's a story for another day. So in that sense, it's like now we can think of abstraction like EC2 versus lambdas. Again, blue one, we own, yellow, AWS. And we reach into the lovely feature. So if we talk about it, we try to kind of explain each layer. But I lie. And I lie because, yes, if we see it from a purely kind of mathematical engineering standpoint, we might find like a function that gives us the optimal choice based on the features of the service. But to be honest, the more complicated part that we need to deal and we should be aware of, and we need to consider, it's context. And context is going to influence every decision that we take. Or as we developers like to say, it depends. On what it depends? Well, what are the use cases? Like, what are you actually trying to achieve? What is your budget? Like, can you actually spend money trying to learn a technology knowing that is maybe it's gonna take consulting or some more resources? Like, how fast do you need to go? Like, do you go for a technology that you already know, or do you go for something that you don't know but might be a better decision down the road? Like team expertise again. Like, let's say that you have 15 years of combined expertise using relational database. Should you jump into trying to use NoSQL right now? Maybe not, maybe yes. It will depend. How fast and how much do you plan to grow your business? Like in terms of users, in terms of capacity, it will affect heavily the decision that you take. And how big is your team, or how big do you want to plan your team to go? For example, attracting talent might also fall into this. Like, are you using a technology that might be more enticing to reach new talent, or are you using a language that is kind of getting into the old side and deprecation of as an industry, seeing how widely it's used? That will affect how you see about this specific point. So what can I do? And here we'll go into the more specific, let's say, sharing tips. Let me be frank. What I'm going to say is based on my experience of 15 plus years of being a software developer and being as any other Homo sapiens sapien. I have biases. So please, everything that I'm going to say, take it with a pinch of salt. So what can I do? Developer's edition. Rule number one. Like, I throw you like a lot of icons in the beginning, like 200 plus, but it's impossible to start like learning all of those. I will even question if we can learn all of them, like truly learn all of them. But my point in here is, or my suggestion from number one is learn one thing at a time, maybe two. And how do we do this? Like the first part will be how to learn. And hey, Gustavo, yes, it's an amazing talk about metacognition. Okay, bear with me. It has been really valuable for me, so maybe it's valuable for you. There are a lot of studies conducted in how musicians and professional musicians learn a new music partiture. And they identified two commonalities that they saw in them. The first one is that they saw that they practice almost every day for around 4 to 5 hours of intense focus. So this is the first key that I call having discipline. Like they were nailing at least 4 to 5 hours, intense focus, no distraction. For us, knowledge workers, it means ideally no social media, ideally less distractions from Slack, ideally in an environment that you don't get too many questions answered, or you can really sit down and focus on what you're doing for those 4 or 5 hours. Musicians actually didn't train more than that per day. Like the rest was doing something else. And the other point, and this is very interesting, when they were learning this music partiture, first they try the whole thing from top to bottom. But they will identify the parts that they were most difficult for them to play. Like those parts that when you try to learn something and you say like, this I don't really understand how it works, or I just check that checkbox, but honestly, I don't entirely sure what it does. Like musicians actually nail down those 4 or 5 hours of intense focus. Actually, they focus more on the parts that were hard for them to play. And they even do things like increasing the tempo to actually increase the difficulty. So when they lower the tempo to the one that they have to play, they were more skilled and it was easier to play. So the other part is what I call deliberate practice in this case, which is focusing on those parts. Because think about it. If you say something like, hey, I want to learn a new language, and the first thing you do is like maybe do a hello world or follow a tutorial, which is most of the time copy pasting. At that point, did you really learn something or you think you learned something? So challenge yourself. The next time that you want to learn something, you can watch the tutorial, delete everything you did, close the tutorial, try to reproduce it. Try to do it from scratch, even if it is a simple application. And take note when you get stuck or the parts that you say like, this actually I not really understood how it works. You can go back and look at the tutorial, but the idea is to really force yourself to try to do it and see how the challenges that you find when doing it. This is what we call deliberate practice. And for me, two of the books that have been really marked a before and after that I will recommend to you, up to you if you want to learn, read it. Number one is Deep Work from Cal Newport, talking about discipline and how, especially for knowledge workers, and what it means to getting deep work done, which is intense periods of concentration and hard work. This is a good book. The other one is Atomic Habits, which by James Clear. This actually helped me change a lot, especially my environment and how we approach to habits that I didn't find that they were helping me achieve my desired goals. So I recommend them. Check it out if you can. But this is how to learn. The other part that I want to focus is what to learn. And this is the kind of the key question with the 200 plus services. And this is talking about priorities, like what do I choose? And honestly, what I did, and I will call my mental framework for prioritization, is actually going back to my 15 years of experience and trying to trace back the decisions that I make and how I was making them. At that time, honestly, I had no idea what I was doing, or I had some idea, but now looking at it in retrospective, it's way more easy to understand. And I codify something like this. Like I have 4 spheres of influence. I have what I like or what you like. I have what you know, what the industry needs, and what the business needs. And before I start breaking down this diagram, I want to emphasize 2 things because I kind of divide this into the me section and the them section. And especially nowadays with social media, maybe you're trying to find information and such, there is a tendency for extreme polarization of topics. So in order to get more clicks or more attention, they will go to the extremes so they are more enticing to watch. But the idea is that you should not try to push or deviate too much into one or the other. Ideally, you want to look this as a whole, as an us, or as a relationship. That means be professional, respect others, and also respect yourself. Like if you see that the variables are deviating too much in the other direction, you can also push back. That's okay. But try to not go to the extremes. That's bad. But what do we learn and how we learn? So I saw this as a professional career. Sometimes we get anxiety, sometimes we want things fast, but think about it as a time lapse. This is not something that is today, it's today, tomorrow, and 10 years from now on, hopefully, if you really like this career. So it will depend on what point of your career you are and what are your expectations. But let's start for the beginning, like you are here. This means you're looking for your first job. So I will say focus on what you know and what the industry needs. That's it. And the question that you want to pose in here is find something that the industry finds valuable. So this is actually acquiring a new skill that you don't have, or you find something that you already know that you can start leveraging. For example, if you want to learn front-end, maybe focus on just one language and one framework. Please don't learn the 14 different flavors of front-end frameworks. Focus on one. Ideally, the one that is mostly used across the industry. You might choose React. Choose whatever. If you want to, for example, learn databases, look at the one that is mostly used on the industry. If you look at some DB graphs, you will see that relationals is like 80+%. Pick a relational database, choose one. That's okay. But start from something, like pick one thing and start nailing on it. At some point, you will transition into the next stage, which is either your first job or your first years. And this is when you introduce the what the business needs sphere. And the question that I want to pose, or you should be posing yourself, is how do I add value into the business? And you will be finding around this area ideally. And in here, I want to give an advice for engineers that it took me way longer than I needed to understand. Like, as engineers, we like technology and we like shiny stuff, but we also need to understand that engineering is something that is a function of the business and is actually trying to help achieve the goals of the business. So if you see it that way and you start looking how the business works and how can you add value into that, that is going to be way better than most of the starting engineers. Like you will have I will say, an advantage that you can leverage with the business. And doesn't mean that you stay in the same business, you can change business, that's a different story. But try to understand how the other parts work and why are you doing the things that you're doing. And not just because, hey, this is a cool technology, I want to use this for something. Still valid, but there has to be a balance. And I would say, remember that you're in a season of learning. So if you have to make a choice between either pushing for a job that is going to be repetitive but pays most versus a job that maybe is less repetitive, is way more interesting for your career long term, but maybe pays less, you have to value those. I personally, when I was in this stage, I value more the experience for sure, but to each one their own. The next stage, I will call it, is kind of the next season. That will depend. I cannot put a year, but I will say around 5+ years, kind of more senior engineers talking about. And now you're starting to introduce what you like. And I didn't introduce it before because I honestly believe that it's really hard to like something that you are not good at it. What do I mean? Like, let's say that you only know how to use relational databases, going back to databases. Well, maybe you start using those and having a lot of experience and say like, hey, I really like databases and I really like relational databases. But because you don't have experience with the others and the others work in a different way and you feel you might feel challenged or you might find it difficult, you start kind of rejecting those others. And that's the problem. So ideally, don't say I don't like. First, try to acquire more knowledge, try to do more stuff, see what the others are doing, and then at some point you start forming what I call your professional identity. And here we start balancing the needs of the industry, so what is actually the hot stuff versus what you really like and you have more knowledge into. Like, you don't have to follow the trend. I will actually don't recommend that you follow the trend. Otherwise, it's gonna be a hell of a ride. But notice that I was always pushing you a little bit below the what you know. Again, I want to push your knowledge. Like, we want to keep learning stuff and seeing how other things work. We might specialize in something, and this is actually my next point, which is once you advance your career and you find your personal identity or your professional identity, as you start asking the question, like, should I specialize or not? Like, should I go really deep into something, or should I go more wider into more stuff? Ideally, you have something that you're really good at and people identify you as a go-to for some stuff, and then you can go as wide as you want. And ideally, at this point, you find, or the whole point of your career is to try to get closer and closer to the circle and to the middle. And this is the point that you acquire knowledge that the industry really values. And as such, you find a business or you're working for a business in which you use that skill and you also like that skill. So that's kind of the whole point. But to be honest, like, life will happen, things will happen, and you will move always around the circle. But again, the idea is to not deviate too much. Remember that it's a me versus them. It should be an us and a relationship. Be professional, respect others, respect yourself, but try to find a balance. At least for me, that's the idea that I strive. Always stay in that middle area. So this second rule that I want to share is, I kind of hinted this when I was talking about databases and features. That is, try to focus on the high-level concepts. And what I mean for this, the base example I will use the same. Like, if we talk about specific services, we might look at things like RDS, Dynamo, Elasticache, Neptune. But the idea is I'm naming specific services that AWS implements. But we can group them somehow based on features, on some common groups. In this case, for example, databases, we can look at relationals, key value, Y column, reverse index, column, graph. And the idea is that these give you a sort of an abstraction layer that will simplify a little bit the complexities when you have to choose one or the other. Because you don't have to learn, or when new services start popping up. Because let's say that Dynamo is just getting into the industry and you don't know what it is, but you say, like, based on what I know, I think it is a Y column database. You start reading a bit and you see, like, yes, it's a Y column database. Now you can transpolate the things or the commonalities from that group to that service, and as such, you already start considering decisions based on that. Otherwise, it becomes too wide of a problem. You can try, but honestly, this has served me a lot to try to group things into common groups with common features. The other, for example, is if you think about languages. For sure, if you are gonna tackle Either you want to move into another direction, and that is predominantly using a specific language, learn the language, for sure. But another consideration is, for languages, for example, is the programming styles. Like the good and old object-oriented programming, like we know it, but nowadays we are seeing functional, and functional features sparkle all over other languages. Like this is for no reason. Like we see some benefits of functional programming that we are trying to get more and more into other languages. So maybe instead of trying to learn a language, try to learn a different style that you might also port into your existing language. We have something like reactive, for example, that was hot at the time, I think. Nowadays, I don't know, honestly. And for example, one that I learned not so actually very recently was data-oriented programming. Not to confuse with data-oriented architecture, two different things. But this, for example, is particularly good for when you have to do your code CPU cache friendly. What does it mean? When you are in a constricted environment where your resources are limited and you cannot increase them. Embed devices, high frequency trading, gaming, to name a few, are the ones that come to my mind. But again, now understanding this, I have another tool under my belt to consider, but it has trade-offs. And rule number 3, try to expand your tool. And I have a really funny example, I guess. Yeah, it is based on a real example, or so reflection of. Let's say that I have the following model. I have Sarah. Sarah is a friend of Will. Will is a friend of Violet. And they are all customers of Amazing.com. You might see where I'm going, but bear with me. And let's say that I want to post the following query. Retrieve all friends and all friends and friends, so two-level indirection of Sarah, that are also customers of Amazing.com. And let's do an exercise. Let's say that I want to solve this the relational way, so using a relational database. So I might create something like a things table and do something like a D, name, and type, and create some entities like Sarah, Will, and Violet, that they are persons, and Amazing.com, that is a business. And I might create another table that is relationships, something like this, of course, foreign keys. And the idea is describe the relationships of the other entities. So Sarah and Will are friends, Will and Violet are friends, and everyone is customer of Amazing.com. People that know relational, so far so good. Maybe you might model this differently. For sure, there are different ways. But the idea is that you can solve this in this way. Let's try to actually solve the exercise. Given this model, let's try to make the query for it. So first, I get the friends that they are also customers of. So friends of Sarah. And actually, I was kind of lazy, so I hard-coded the IDs in this case. Forgive me, but it was getting longer. So I get the first level in here because it's direct friends. But I also need the friends of friends, so two-level indirection. So I might use like a union, having another select, way more showing. So showing with friends of friends, showing with customers. So I get what I need, but I have the IDs. So I need one extra step, which is another showing. And now I get the names. Voila. But let's try to do it a different way. And this, I'm going to call it the graph way. And let's say that I do something like this. I create 3 entities that they are persons with different names. I define the relationships of friendship. I create another entity that is the business. And then I define the relationship of customers. And I'm going to bet you something. Even if you don't know graph databases, if I hide this diagram and based on this text, I tell you, please recreate the diagram based on this text, you most likely will be able to do it. Like if you read it, you kind of get a sense. There are some weird brackets and double points and what is the arrow thingy, but you might get a sense for it and you can do it. So you already see the difference in complexity. But let's try to answer the question actually. So you might have something like this. You start from a person, travel the friends, that one or two is just two level in direction. You link the friends with the businesses that they're a customer of, and then you add the filters. You start from the person which name is Sarah, and you make sure that all the friends are also customers of amazing.com, and you return the name. And let me put it in comparison to make it more just. I even have to shrink the size of the font to make it fit into the image. Which one do you think, like if I have to say, which one will you choose? What will be your answer? Sorry, I need some water. Let me give you one advice. If your answer was immediately number 2, like the graph, again, the idea is not to focus only on engineer. Yes, it was a tricky question. It's only think on the necessities of the business. Like, just if you're looking from an engineer perspective, yes, you should try to do the right one because the left one is introducing what is called accidental complexity. So now you have to solve 2 problems. The initial one and how to deal with the whole relationships and normalization. But let's say that we really care about the business and we start asking questions. Like, for example, how often is this gonna be executed? Like, is something that we are exposing to customers, or is something that maybe somebody from the analytics team is gonna use it once every month? Did it change your answer? Now we are seeing, like, again, think on the context. Like, if you think about, like, okay, if we are going to expose it to the customers, how much are we going to change it? It's like, this is the only use case that falls into the graph kind of access patterns, or we will start seeing more and more. Maybe we can start with the relational if we already have a relational database in place, or if we are starting from scratch and this is our main use case, like everything falls into more the graph idea, we use the graph database. But again, what I want to take from this presentation is stop thinking in absolutes. Start challenging and see what the context is and the context of the business also, and ask those questions. Because, for example, if you already have a relational database and you introduce a graph one, it's as simple as more databases, more complexity. Yeah, like you change code complexity for architecture complexity. It's not that it's for free. So there's a caveat, like who is the source of truth, how you're gonna do the syncing within the database, who manages the reads, who manages the writes, like all those things you need to have into consideration. So it's not a yes or no answer most of the time. And that's why context is, for me, the most important part to consider. But again, if you're starting from scratch, no doubt, I will go with graph databases if it is a graph access pattern. So to recap, number 1, I would say learn one thing at a time. Remember how musicians did it. So think about discipline and deliberate practice. Remember the books, the work and atomic habits, and the mental framework to actually choose what to learn. And this, remember, that changes depending the time and place on your professional career. The other point, and my mascot is getting away, sorry, high-level concepts, like focus on high-level concepts instead of learning just specific ones when you can. Again, object-oriented versus learning one particular language, or maybe wild column instead of learning DynamoDB. And then number 3 is try to expand your toolbox. Remember the graph case and be wary of accidental complexity, but also be wary of context, and everything is a trade-off. So maybe introducing another database might not be the optimal choice, maybe yes. So what can I do, CTO or tech leads or anyone that has to really need to take decisions? Yes, the first point that I will say is really understand that. I think everyone, even engineers, should understand that, but CTOs are way more pressed to master this concept. Let's give a quick example. Like, let's imagine that I want to buy a house, cut and dry, and I want to ask for a loan to buy the house. Is it a good or a bad decision? If you answer immediately or in your head or just mumbling, yes, no, or something around those lines, well, you might be akin to what I'm going to say based on my presentation. It depends on the context. Why? Because let's look at, like, for example, if you ask for a loan and you pay the down payment, do you have savings to cover for a rainy season if that happens? Like, if you're in zero in your account after the down payment and something bad happens and you need an extra cost, now you are maybe forced to sell the property or get another loan. Like, not a good scenario. So that was our decision made. Do you have source of the income? This is kind of to counteract the fact of rainy season. Like, if you have more than one source of income, even like if one actually goes down, the other might be coping with the load and it just be fine, or you might get into the red. I don't know. It will depend. But more importantly, and this is something that you should ask, is why are you buying? Because this will really change the factors that you consider. Like, if you are going to buy just for living in that place, as long as it's livable, that's okay. Like, you don't care how much. Are you buying for renting? Now you're getting more operational overhead because now you will have tenants. And you either have to deal with the tenants or you deal with a company that deals with the tenants. What about if you're buying the house to flip it? Either you really know about renovation and you have the time and you want to do that work, or you are really good dealing with contractors and have the money to pay the contractors to improve the house so you can actually increase the value of the home. Otherwise, might not be a good decision. Or you might buy it just to have an asset and change cash to something more physical. But again, think about how just answering this question made you change all the factors that you consider and how you will approach that decision. But this is houses. Let's talk about technical stuff. So if you look about what I call the most influential devs in terms of software engineering, I will say the first one we are commenting is technical debt. Let's use the databases example because I like databases. It will depend because, for example, ask yourself, based on the particular use case, do you need the scalability that a wide column database or NoSQL database provides? If the answer is no, do you really need to choose that, or you can go with relational? How much do you expect to grow and how fast? Is this like a linear thing? Is it an exponential thing? Do you have a marketing team that you know that is preparing something like a big push that is going to bring a whole lot of customers in really short time? Like, those things will influence which decision you make, because you might take some technical debt, going with relational, deciding to transition at some point, but marketing might force the transition sooner than you expected. What about the expertise of your team? Like, again, you might have 15 plus years of combined expertise only on relational databases. If you decide to go with wide column, just with that team, at that point, you are experimenting. Like, be honest with that, it's gonna take some time, you will make some mistakes, so consider those. Like, that is a trade-off. The other one is the all good and known, and this is more for C-level executives, financial debt, and this is the all OPEX versus CAPEX. Those are the parts that I hear the most talking about. But there are other aspects that I should say we should consider about financial debt. Like, for example, time to market. Again, based on a technical decision, you might delay your time to market, which might have repercussions. You might lose market share. or might lose the competitive advantage to a competitor. Is that a good thing? Is that a bad thing? How much it is? It will depend. But it's like a technical decision trickling down into financial debt. Operational overhead. Again, we keep trading kind of CapEx versus OpEx. You might choose with a service that is more managed, and the solution is just add more services. That will increase the OpEx. At some point, you say, hey, this is too expensive. We change to something like more, we manage ourselves. And then at some point, you need to ramp up your team. Sorry, you need more people because you don't have expertise, so you need to get it outside. So this is don't take this in isolation. They are all interconnected. But the other one that I don't hear talk about much, and I think is kind of really important, is the ignorance debt. Don't take ignorance as a bad word. Like, the idea is like you are ignorant in the sense that you don't know. Oh, this is also the unknown unknowns. Like, if you have to choose between, for example, relational and white column, but you didn't know that white column even exists, is that a choice at any point? Mostly no. You went with relational. But if you need the scalability, then later down the road, you will find some bottlenecks. And this is because you didn't even know that something else existed. And I think this is where consulting actually comes into the picture, because the idea is that with consulting, what you are trying to do is kind of trade off these steps. Ideally, what you do is you pay for a consulting team to bring all the expertise and ideally remove part or all the ignorance debt and the technical debt. So we pay for that expertise, and as such, you move the balance of these levels. But again, think of the problem that I see the most is engineers focusing too much on the technical aspect and C-level executives focusing too much on the financial aspect. I wanted to do the interconnections between all boxes, but at that point, I basically recreated the spaghetti monster, so I removed it. But think of this as a system of interconnected levers. Like, if you push one too hard, it's gonna affect the others. So take that in consideration when you take decisions, and don't look them in isolation. The rule number 2, and related to the middle one, which is financial debt and some technical stuff, is more expensive can actually be cheaper. Sometimes, context. So, and this is something that I hear a lot from C-levels, and I hear it in a more imperative fashion, but I will pose it more like a question, which is serverless expensive? And again, if your answer was to immediately say yes or no, or a friend told me, or I read somewhere, stop. It depends on your context, and you should consider it. The most basic form to compare it is CapEx versus OpEx, and we saw the EC2 versus Lambda approach. Remember how much and what are the things that you need to take ownership versus the ones that you are delegating to the cloud provider. And let me hint it for you. Like, all this red stuff, the question is, who is the responsible for now if you choose EC2 instead of Lambda? And the answer, you guessed it, is correctly, is you are responsible for this now. So saying that something is cheaper or expensive just by looking at the dollar sign attached to the service is not the whole picture, and might do you some more harm than good at some point. So, for example, what is your budget? Like, do you actually have the budget to maybe invest in learning, invest in the team, invest in bringing knowledge? If not, what is your expertise? Consider it. What is the deadline? Because right side is less stuff, left side is more stuff. Which one do you think you're gonna make faster? Deadline is a factor to consider. Is this a one-off or is reusable? Like, if you are managing a department, think about it this way. Can you move the budget of this of the team that is going to be managing the red parts as a separate department? that is going to be serving other departments inside the organization? If the answer is yes, then it is more enticing to actually do something that might yield returns on a different scale. But again, it will depend on your context. So think about it. Team expertise, you are kind of getting into the technical dev, trickling down into the financial dev. So be aware of that. Team size, now you need to do more stuff versus less stuff. Do you have the people to actually assign to be owners of this? Is gonna eat from your capacity to actually provide the features that will give you more market share or not? Those are questions that you should pose. Time to market, again. But more importantly, like, okay, let's go like full mathematicians. Like you say, no, I really want to compare dollar signs. Okay. Can you tell me what is the maximum capacity that one of your services provides? Like maximum requests per second, for example, that you can serve. Okay, you have that measure. Now we put a dollar sign comparing to how many lambdas based on average execution you might be running. And what you want to find is the mathematical limit between like what it costs so many lambdas and what it costs your EC2. And what you find is a limit on utilization of your EC2 instance. I cannot give you a number because, again, it will depend on your benchmark. So don't look at other benchmarks because they are not yours, they are theirs, and they are different. But the idea is that you find a utilization percentage that if you are at that limit or above, then EC2 becomes cheaper in terms of operational expense, like what you pay for being running the service. But then I ask you the question, like, can you ensure that your services run most of the time at or above that CPU utilization? If the answer is no, then is it really less expensive? I don't think so. And again, this is not me saying that Lambda is best and EC2 is worse. No, I have seen examples in which EC2 was clearly the winner in terms of just raw monetary expense. There are examples. But again, think in the terms of all the other aspects that it will take. Don't just rush to a decision because you read somewhere or you saw something. Like, that's not what I want you to take from here. Like, think of all the context around it and find your solution better. In this case, yes, you can use mathematics. And the third one is build expertise or buy. Like, we cannot talk about the ignorance depth, but I think it's really helpful for organizations to think into this in short-term and long-term kind of format. Like, for the long-term or long live of the organization, what I want you to think about it is something like a mastermind group. You might find it referred to like culture of knowledge, but the idea is that you start building an acumen of knowledge and also people that you find accountable for specific either technologies or decisions in your organization, and you start involving them. And for engineers, if you're getting accountability, we respond with responsibility and also accountability. So again, this is a relationship. But the idea is that you start building this acumen, and this is a long-term investment that you're starting to do in here. But what about the short term? You say, okay, for the short term, the thing that you might do is either find talent, either find more experienced people, or you can get consulting. Consulting is the idea to bootstrap on the short term. That's the main idea of consulting. Like, you bring resources to get things done now and get that expertise that they gain from past experiences. And you don't have to pay for them. You just pay for actually implementing that. And you have different ways of consulting, like you have the do it for you, do it with you, do it yourself. Like, ideally, what I want you to consider is a mix of both. Like, this is the ideal if you're not sure and you want to get the benefits of both. because what you do is you pay to get consulting to do it with you. So think of it staff augmentation. You bring it into your team, they already bring the expertise, they help you bootstrap the stuff faster, they help you remove ignorance and technical debt, but they also help you train your team, and your team actually feeds from that knowledge and starts growing the internal knowledge inside the organization. So they kind of retrofitting itself. So on the short term, you kind of get a boost, and in the long term, you still building that knowledge acumen that you really want to cultivate in your organization. But as I said, recap, understand that. Again, good or bad will depend on the context. Don't rush to say yes or no. Look at the context and take a decision based on that. And look at the whole system, not just one vertical in isolation. Number two, expensive depends on context, and mostly a trade-off between operational capital expense, but think of all the other stuff when you have to take a decision. And if you want to simplify, it's basically delegation of responsibility. How much do you take versus how much do you pay for someone else to take the responsibility away from you? And number three, build expertise or buy it. Ideally, mastermind group, hire outside help, or mix the both, the best of both worlds. And just to recap, like if anybody after this presentation asks you like, why is the cloud so complex? You can say it's because amount of services multiplied by the amount of features of each service, multiplied by the level of abstraction of each service, and taking context into consideration is what defines the complexity of the cloud. With that, I hope you take something out of value of the presentation. If you don't agree with what I say, but at least find discussing these ideas, mission complete for me. So I hope you have a good day, and let's open if there is some Q&A. I can't see anything, so Danny, I think I got over that.
Hi, Gus. Thank you so much. That was really, really amazing. Not only it was super clear, but very detailed. So thank you so much for everything you share with us. I also want to take a small opportunity to thank first our amazing designer who helped us to put this presentation together. So thanks, Car, if you're watching. And also I want to thank, of course, everyone that joined this session, our team that I know is watching. So thank you guys, and everyone else who took the time to listen to Gus. So now, before we leave this session, I do have two questions for you, Gus. The first one is that I noticed that you scratched the word simple in your formula slide quite at the beginning. Was it for a specific reason?
Yes. Well catch. Actually, it was more of actually making fun of the decision naming of the first services of AWS. I think engineers try to put simple on the naming, just thinking that will make the service simple, like simple queue service and simple storage service. Like in the end, it's never the case. But yeah, I was trying to make
the only simple thing was the name, right? In that case, I hope that after this session it became a little bit simpler for everybody. So thanks. And my second question is, when you gave examples or you give examples, you usually talk about data, right? And or most of the cases were around databases. Is this for any particular reason, or do these examples only apply to these services only, or how does it work?
Okay. So no, these examples apply to the whole spectrum of services in AWS. The catch is if you pay attention to my mental framework and one of the particular spheres, which is what you like. In this case, you is me. And in this case, I really like databases. So when I had to think into an example, the first thing that popped into my head was some database-related example, and that's what it ended up in the presentation. So if you don't like databases, I'm sorry.
But it works for anything else, right?
I hope that you can transpolate that to other services.
Perfect. Thank you. Thank you so much, Gus. Okay, we learned also that you're a database fan, which is great. And also great to know that all these ideas apply to all services. That's excellent. I think we've run out of time today, so I want to thank you again and everyone on the other side of the screen for your time and this excellent session today. We'll go through any pending questions and we'll make sure to answer whatever is pending through our LinkedIn page. So we invite everybody to follow us. It's valuable content only. You can also learn more about NaNLABS at nan-labs.com. And of course, you can contact us to continue this very interesting conversation through any of the channels. Before I forget, we're going to do a draw among everyone who registered for this webinar for a free consulting hour. So we will record that draw. We will share the winner's details on our LinkedIn page as well. So another good reason to follow us. Now we wish you an excellent day and we'll see you at the next webinar. Thank you for now. Thank you, Gus. Bye, everyone.
Bye-bye.
Bye.